Okay, question number 16 says, use your calculator to find this function's x-intercepts, holes, and asymptotes. So what we're going to do, we're going to go to our calculator, and we're going to type in our function. So what we'll do is we're going to use parentheses for the numerator. Numerator is x squared minus 3x minus 10. Close parenthesis, we're going to use a division bar, and then I'm going to use parentheses here for each one of these factors. We've got x plus 2 and x minus 5. We've got x minus 3. Now what we're looking for, if any of these will actually cancel, meaning divide out, they're a factor of the numerator as well, then it'll be a hole in the graph at the value that makes it 0. If they don't cancel, it'll end up being an asymptote. We're going to go to zoom standard. Now it looks like 2 of these values are going to cancel out, and if we blow this up, we'll see that x equals 3 is going to be the asymptote. So when we go to classify these, this is a hole in the graph at x equals -2, because that would mean division by 0, which is a big mathematical no-no. And we'd have a hole in the graph here. Right? And then this ended up being an asymptote because it did not cancel. So that's what creates one of those lines that our graph gets really close to, but doesn't technically reach. Now the x-intercepts are going to be any place that it crosses the axis. So go back and look, and it looks like we never actually cross the x-axis. It gets ridiculously close to the x-axis. But there aren't going to be any times that we're able to make this function equal to 0. Question number 17. Convert the equation to rational function form. Rational function is just when we have a function on top of a function. So what we have to do here is get a common denominator. So I'm going to put this over an imaginary 1. And in order to be able to add fractions, I just need to have the same denominator. So what I'm going to do is I'm going to take this first fraction, and I'm going to multiply it by x plus 5 over x plus 5. I can always multiply a fraction by 1 to change its appearance. Okay, so when I do that, I'm going to get, in my numerator, I'm going to do the use of FOIL method here and get x squared plus 5x plus 3x plus 15. And now that I have the same denominator, I can also add that 1 and put everything over that common denominator that I found. And we'll just do one last cleanup, which would give me x squared plus 8x plus 16 all over x plus 5. Okay, question number 18. Factor the following. When we factor, if we have an a value of 1 like we do here, what we want to do is I want to come up with two numbers that have a product of 60 and a sum, or product of -60, excuse me, and a sum of 4. So what we're going to do is we're going to write out a couple of them, like 1 and 60, 2 and 30, 3, 20, 4, 15, 6, and whoops, I forgot 5 and 12, 6 and 10. And then we're going to look at these and see if any of these could be added or subtracted in some way to get a 4. And you'll notice that 6 and 10 have potential. So let's take those, and what we're going to do is we're going to break this up. It's nice to have an a value of 1 because then we can just put x's here. We know that we have one negative and one positive because we've got a product of negative 60. Now I want the sum to be positive, so what I'm going to do is I'm going to make the bigger one the 10, or excuse me, I'm going to make the 10 the positive, and I'm going to make the 6 negative. That way when I add negative 6x and positive 10x, I'll get that positive 4x. So this actually works out there. I've got my first times first, x squared, outer plus inner as a positive 4x, and negative 6 times 10 as a negative 60 for the last. Okay, divide and reduce all common factors. So what we have to do here is we have to factor. This is reverse FOIL method. But what we're going to want to do is we're going to want to factor all this stuff out, and we're going to want to see if there's anything that we can do to simplify this. So right now I've got d plus 6. I know that I can factor my numerator. I'm not going to write this with division. I'm going to use the idea that dividing by a fraction is the same as multiplying by the reciprocal of that fraction. And therefore, when I show this down here, I'm going to flip these. So that means I'm going to put as my, what would have been my numerator, d minus 7 times d plus 7. That's the difference of two perfect squares. You'll notice when you FOIL those, you don't end up with a middle term. I'm going to put that as the denominator down here. So I've got d minus 7 as one of my factors and d plus 7 as the other. And looks like I'm gonna need to factor this one for here and this one for over here. So let's do the d squared plus 13d plus 42. I know that's d plus and d plus. Product of 42, I'm going to go with 7 and 6. That's from my times tables. That's the first one that jumped out at me. And fortunately, it gives me that 13d when I add the outers and inners. Over here, we need a product of negative 12 and a sum of positive 11. So when I'm choosing these, I know that I'm going to be dealing with a 12 and a 1. I'm going to want to make the 12 positive because the 11d is positive, the sum of the outer and inner, and this is going to be negative. Now I'll just look for anything that I can get rid of. Anything that shows up in the numerator and denominator, it's like multiplying by 1. A number divided by itself is 1, so I'm going to, basically we're replacing those with 1s. d plus 7, d plus 7. I got d minus 7, d plus 12, d minus 1. Can't really work with those, so in my final answer, we've got d minus 7 was all that was left in my denominator. But in my numerator, I was able to cancel a few things, and this one's just going to either remain in factored form if that's one of the options that you run into, or you can simply FOIL it back out. We had factored it, so I didn't have to do any tough work. I just replaced it.